go one bulb, one resistor. So let's say the power in one is, let's go 40 watts. And let's call resistor 2 having a resistance of, let's just go 10 ohms. And then my voltage source is going to be 120 volts. And let's say I have an ammeter sitting here, and this ammeter is measuring the current I2, and I2 is, I'm not going to give you that actually. I'm not going to give you that. Okay, let's just stick to this. Yeah, you don't need that information. Okay, so this is the information I've given you. As you can see, I've added power into the equation. So once again, with power, power is always additive, so P total equals P1 plus P2 dot dot dot. That is one of the things that is consistent between series circuits and parallel circuits. So we're also going to just incorporate it straight into our RIV chart as we have previously in the circuits part of the unit. We're going to label the number of resistors we have. So we have a bulb and a resistor, and we need a space for total. Now I'm going to write in all of my knowns. First known is power for lamp 1 is 40 watts. So I'm going to write that in. We have 40 watts. But number 2, I only have a resistance, and that resistance is 10 ohms. Okay, so the other piece of information that I do have is I have my total voltage, which is 120 volts. I just kept it standard for these, but you'll see some variations in some of the problems I assign you. Okay. Well, first of all, we always want to ask ourselves, what is the same everywhere in a parallel circuit? And we know it's the voltage, right? So we know the high voltage end is 120 volts, the low voltage end is 0, and that voltage drop needs to happen across the resistor. So each resistor has 120 volts on the high end, 0 volts on the low end. So let's take that first thing that we know and say, well, V total equals V1 equals V2 equals 120 volts. So I'm going to write that in everywhere so that I remember that this is a known piece of information to me. Now we can really go wherever we want with this because we have enough known information in most of these places. I'm going to suggest just starting at the top. So I'm going to start here first and find my current. And honestly, once I've found my current, I might just find my resistance. So I might just do this whole top row first. Okay, so first I'll use P equals IV, and then I'm going to use V equals IR. I hope that doesn't get confusing. Let me get rid of that. Okay, so step 1, I'm going to use P equals IV because I want to find I1. So P1 equals I1 V1. Right, that's our power formula. So 40 watts equals an unknown current times 120 volts. So we have 40 over 120, which is going to be 0.3. I'll not round. I'll just do 0.33. Okay. So we have I1. I want to do the same for I2. But for I2, unfortunately, I'm going to need to use Ohm's law. So for I2, I'm going to use V equals IR. So V2 equals I2 R2. So I have 120 volts equals an unknown current times 10 ohms. So I2 is obviously going to be 12 amperes. And then you can really take this the rest of the way. So I can use V equals IR up here to to figure out my resistance across resistor 1. Let's do that. So let's just say V1 equals, I'm out of space, I'm sorry. I1 R1. In other words, 120 volts equals 0.33 amperes times R1. So I can do that now. So 120 divided by 0.33. So this is going to be like 360 ohms, R1. 360 ohms. I can go down to row 2 over here, and I can figure out my power rating if I wanted to using P equals IG. So let's just do that. So we have 120 times 12. So, wait, what just happened? 120 times 12. So this is going to be 1440 watts. So I just use P2 equals I2V2. So we had 12 amps times 120 volts, which gave me 1440 watts. I could go down to the final row, and in any order that I choose, I can fill in the rest of these. So we know for current, this will be easy to do because I total equals I1 plus I2. So it's really going to be just 12.33 amperes. And once I know that, I can use V equals IR. So V total equals I total times REQ to solve for my equivalent resistance. So 120 divided by 12.33. So my equivalent resistance is 9.7 ohms. And my power, I can multiply current times voltage. So I'll do 12.33 times 120 volts. So I got 1480 watts, which is nice because we know that this plus this should equal the total power. And so everything checks out beautifully. Okay, that's it for parallel circuits.